So the topic for today is running GenAI on your enterprise data at scale. So my name is Ton van Oten. I'm CTO at Noest. With Noest, we build solutions on the Microsoft stack to make sure that life of our customers, the world of our customers, gets smarter and more efficient. And we do that with a local group of enthusiastic people. So we are active in the left side of Belgium, so the west of Flanders and the east of Flanders. And from there, we try to make a global impact because our customers are globally active. Next to that, I'm a dad of two fantastic kids and a big cycling fan. So, on the agenda for today, first of all, an introduction on LLMs and tools, because everybody here is talking about LLMs, tools, and so on, but I really want to explain you the basics, how it works, how is an LLM actually able to access your data. I think that's a very important one to get everybody on the same page. Second, how can we do GenAI at a larger scale within an organization to get rid of just prototyping and proof of concepts, but really to go in a mature state. Next, I want to show you a real world case. Of course, a demo version of it because we cannot share the real data, but at least that's an important one. And then last but not least, lessons learned. I think we did a few GenAI projects and we made a few mistakes, of course, and I want to share these learnings with you. So first, an introduction on large language models. So an LLM is nothing more than an API. So don't be afraid of it. Whoa, all that GenAI, it's too complex. No, it's only one API call away, so that's very important. You can host it yourself, but typically many organizations choose the cloud-hosted LLMs like Azure OpenAI would be a logical choice if you're already in the Microsoft ecosystem. First of all, you need to send a system message to it, and in the system message, you give some details on how the agent or the large language model should behave. What are the rules that it should obey to? What is the role or function that it's playing, in what context is it active? So that's a very important message. And of course, you have user messages. User messages are coming from the end user or maybe the end processes. In the end, the user message is, if you compare it to the chat, are the chat messages that are originating from you. So those two together are the inputs, and they are sent to the large language model. And based on that, large language model will generate an output, which is called the assistant message. And it's important if you want to have a real conversation, the large language model is stateless. So if my first message is, hey, I'm Toon, how are you doing? And the next time I call the API and I say, hey, do you remember my name? It will not remember my name anymore. So it's stateless. If you want to have a conversation, you need to send the chat history yourself. So you need to send the first message that you sent, the response, so the assistant message that the agent or the LLM responded, and then again. So it doesn't keep history, that's your responsibility, and you need to make sure that you send it with it. Input and output is expressed in tokens. It's the kind of, the unit of language for large language models. And here you see how words are actually split into tokens. Typically, small words map into a single token, and longer words are split. One recommendation here, do not make extensive use of GUIDs in your prompts. Definitely if you automatically generate prompts, because they consume a lot of tokens. Of course, if it's on a high volume, that's not a problem. But if you're regularly using them, it might become costly, because tokens are often the unit of billing. So you need to pay per token, mostly per million tokens that you consume, both input and output tokens. Next to that, also very important, tokens are limited per model. So the number of tokens, the number of words actually it can process depends on the model that you choose. And that's something very important, choosing the model for the use case. First of all, cost is an important factor over there. You have cheaper models, more expensive models. So depending on how many times the LLM will be called, it's important to take that into account. Speed is very important. If you have more a chatbot interface, the end user doesn't want to wait a long time. So then you need to go for fast models. If it's a background process that is consuming your AI model, maybe that's not that important. The quality, of course, the reasoning power and these kind of things are important. And then the context window that it can process, so the number of tokens it can handle. Those are typically the 4 main constraints to choose your model. The good news is there's a lot of competition in this market, so the newer models are cheaper, faster, and better. So that's a positive evolution, so thanks to the competition over there. If we then look at a large language model, what do they offer? First of all, knowledge. So they are trained on a huge amount of data on the internet, so Wikipedia, all information that you find online. So that knowledge is inside the large language model. Language understanding, it can process natural language. It can talk almost any language out there. You can ask a question in English and it can answer in Spanish, for example. Not a problem at all. And it has some reasoning capabilities. It's of course not a human brain, but it has some logical reasoning steps that it can execute. Of course, what's in it for organizations? I don't think it's important to know who's the first president of the United States, so that knowledge is not important. We want actually to use our own data, or company data, organization data. And that's what I want to focus on. How can we now let an LLM, which is actually just an API, a trained model which is hosted in the cloud, access our own data? That's actually what I want to explain now. The answer is function calling. Let me try to explain what function calling is. So on the left side, you have the developer or the code that you write, and on the right side, you have the model. So we are sending the messages. Remember the user message, the system message. But we can additionally, optionally send also tool definitions. So we can give a list of functions that are available for the large language model to call. So we say, hey, if you want, you can invoke this function, and this function. And together with all of that, we send, of course, our last message, what's the weather in Paris? Then the LLM will decide what functions to execute. It might be that it just answers with an assistant message, but sometimes it says, okay, I don't know the weather in Paris, but I see you have a function available that calculates this for me. So instead of calling that function itself, because the large language model is not able to call APIs and so on, it will give the instruction. So in the API response, it will give us the instruction. Please call this getWeather function for me with the location parameter Paris. And then your code should execute that code locally. Now, this could be calling the weather API, but it could also be accessing your own CRM system, going to your own database. And then you return the results to the LLM. And based on that result, the LLM will interpret the results, will maybe try to invoke another function. And in the end, if it has all the information, it will return an assistant message, so a response. So that's very important. The LLM is not calling your code, is not calling your APIs, is not accessing your database. No, it's just giving the instruction, please do it for me and give me back the results. So let's have a look on how that works on an API basis, just to get all the details. So I have here the chat completion API. So we have here an Azure API, Open API, AI, excuse me, service, and we just call the chat, the 4.0 mini model, the chat completions API. So I'm sending 2 messages. First of all, a system message, you're an AI assistant, and the user message is just, what's the weather today? But next to that, I'm sending 2 tools. I'm sending a tool to get the current day time, and a second tool, a function, to get the weather for a specific location. And you see this has an input parameter, location, which has the description, the city and the country that need to be provided. And this is required. So let's call this. So I asked actually, what's the weather today? Well, this is a JSON response that you get, so some content filter, but in the end, here you get a message. Could you please specify me the location? And it's also indicating the city and the country, because you feel it wants to call that getWeather tool, but it still needs a parameter. So let me answer that. So in the chat interface, I'm answering, okay, I'm currently in London. What the API should return is the whole chat history. So again, the first system message, the first user message, then the assistant message, the response that I received, yeah, and then my response that says, hey, I'm currently in London, okay? So we send that history together. I send it to the chat completion API, and now it should have all the information to answer, not with a normal message, but here with a tool call. So here it actually says to me, to the code, to whatever, please execute the function with this name and with these arguments. This is JSON and JSON. So this person is currently, the location is currently London, UK. I only provided London. UK is general knowledge that this model had, so it knew it. And I give it also an ID, because I will now execute this code of call this API locally, and then give the response back, and of course the IDs should match. It should know what's the response. So my code will now execute the getWeather API function, whatever I have, and then we will do the next call. So here I'm currently in London. You have the assistant that asked for a tool call with this ID, and I'm answering actually this. The content, the result of this tool, just 14 degrees, to make it very simple. Now, the model has all the information to generate a good response. So here, the weather in London today is 14 degrees. So that's how it works. The LLM model is not executing your tools. No, it's just receiving from you as a developer or a list of tools it can call, and it will give you the instruction. You are responsible to run it and to give back the response. Like mentioned with the agent tool session, for example, the bigger your responses are, of course, the more tokens you receive, because everything is always an API call towards the chat completion API. So that means also you spend tokens and money on that. So that feels like a lot of plumbing, and I wanted to show you how it works, so that's why I show it on an API basis, but that's not the purpose. But in reality, if you build solutions, you have frameworks for that. And if you're in the Microsoft world and using .NET, Semantic Kernel is probably the best option for you to use. Let's go immediately to the demo. I want to now do the same demo, but code-based with Semantic Kernel, and you will see that it's a lot less work than all the API calls that go from left to right. So I'm here in Visual Studio. I have a simple console application, so nothing fancy over here. And I have here a weather plugin, which has one method over here, the getWeather, with one input parameter location. And I did annotate this method here with the kernel function. And I provide here the name and the description. This is the name and the description that will be passed towards the semantic kernel and towards the large language model. So the large language model will know, there's a kernel function with this name, it has this description, and we have one input parameter, the location. Here we have a little bit of semantic kernel code. Don't be afraid of that. We just have a kernel builder where we add an Azure OpenAI chat completion client. So I just give it our URL, and we use managed identity to authenticate. You can also use API keys. I register here the plugin. So I say, okay, add all the functions that you find in the weather plugin. So this will make sure that this will be sent as a tool in the definition towards the large language model. And all the rest is just some simple chat history. So I create a new chat history object, add a system message, you're an AI assistant, and then we're just looping in the chat. I add the user message and I add the response. So let's press F5. Zoom in a little bit. Hi there. Wasting some tokens, why not? This is answering now without calling any tools, because it has no tools to ask how it's going. But then I can say, okay, what's the weather today? Your English shouldn't be perfect, so you can make typos. He understands everything. Where are you? Is asking. So currently, in London. And now you see my code gets invoked. So my function here, what is it, the get weather function is invoked. The LLM didn't do it, but the LLM answered with a response, and semantic kernel knew, okay, now I need to invoke this piece of code. You get a parameter location, you see it's London, United Kingdom, and we return back here weather. It's snowy and 10 degrees. Okay, that's what you have with random weather conditions. But that's actually what we will now provide to the large language model. So the current window, London is 10 degrees and snowy. Stay warm and safe. So that's how it works. That's how you can let a large language model access your data. Okay. I hope this is clear. If any questions, now the moment to ask them. All right. Next, let's have a look at GenAI at a larger scale. So if I look at the current state in many organizations of GenAI, we see that many organizations are doing some prototyping right and left, but they really are struggling to get stuff into production on a mature way. Next to that, the most initiatives that we see is chatbots. Chatbots is, of course, the most simple thing to build, but maybe the most difficult thing to have a good ROE, so a return on investment. So GenAI gives more value if it's integrated in your business applications and business processes. Often, those AI initiatives, they are done at a very fast way, and they are built on top of a fixed data dump. So we export some data from a database, or we take some documents, and we rapidly build an AI agent on that. Developers are also often a bottleneck, because when you're doing GenAI, there needs to be quite some testing and tweaking of your prompts to make sure that in any scenario that you can imagine, that the bot or the agent behaves like you want to. If it's internal bots and stuff, that's less important. If you have external facing bots, that's even more important. And that's testing, that's typically not what developers are good at. Actually, you want your key users to do that testing, but then they always need to ask the developer, hey, can you change that? Can you change this? So it's often an issue. If they then succeed in building one or two or three agents, it's also difficult to let them communicate with each other. I have now a service desk agent, and I have maybe a CRM agent. But the service desk agent could make use of the CRM agent, but they are not designed for that. They are just proof of concepts, whatever. They are not designed to intercommunicate with each other. And then, of course, security risks. It's often rapid prototyping, let's say, where often security is forgotten. We create a chatbot. It's maybe available through an obfuscated link, but at least everybody with that link can now access maybe the secure and sensitive data that we put in the data dump. If you then look at the current state of GenAI at Microsoft, and this is the current state, but be aware we are already doing GenAI projects for 1.5 years. A lot of stuff is not there or is in preview. Luckily, we've seen nice things being built at this moment. So kudos, first of all, to the API management team, who does a tremendous job on having the AI gateway quite rapidly integrated in Azure API management. And I'm also very pleasantly surprised by Agent Loop. The way it's designed and the future roadmap looks really promising. So it's really a good way to do AI. So I was really positively surprised over there. But it's still in preview. So we have to wait, I guess, a few weeks, few months. But in the meantime, we had to develop already GenAI solutions. So that's why we have built our own accelerator, to make sure that even if we do a small prototype, that it's immediately production ready. So that the security is fine, that the scaling is fine, that the costs are optimal, and these kind of things. We don't want to limit to chatbots, so all the agents that we built are available through a single API interface. So you can easily plug it in your own applications, in your websites, or in your integrations. So if you want to build smart integrations, you can have an API call to one of the agents to reach out for more information. Of course, we don't want to build on top of a fixed data set. So the intention is to have real-time data integration. That's why I'm convinced that if there's one profile out there who's well suited to build GenAI integrations, then it's an integration developer or integration engineer or whatever, because you guys are connecting to various systems day in, day out, and that's actually what good agents also should do, because your data is not in a single software application, it's typically spread across multiple sources. If you don't want your developers to be the bottleneck, you need to give away to the end users, not the end users, but the key users, the people who are typically on the edge of technology and business, give away to let them change the prompts and to see what's the impact of that. That's also very important. And make sure, if you design it, that agents can talk to each other. That's also an important one. And of course, security should be bottom up, so that's why we included Microsoft Entra ID authorization from day one. So the high-level design, without going into too much details, we have a small application for the agent configuration. We need, of course, to execute the agents, so that's the logic to call the large language model and to execute the tools. We need to have large language models. We need to have API with security, and on top of that, we can have consumers who could be anything. And then we need some supporting services like a chat history, because you need to store your chats. You can do that in memory, but if you have long-running processes, it's better to persist that. We need to have a vector database and also some document processing, because you need to often crawl some data from PDF documents, from Word documents, PowerPoints, whatever that is out there. These are the technologies that we use for that. So Semantic Kernel is at the root of everything. It fetches its configuration from a Power App, so we use model-driven Power Apps. They are not sexy, but they are very simple to have, a nice user interface, simple user interface to configure the agents. And we use Azure AI Foundry mostly for the models. Cosmos DB for the chat history, Azure Document Intelligence to fetch the text and the images from the documents, whatever, if it are PowerPoints, PDFs, and so on, it does it for you as a service. And Azure AI Search as a vector database. All right, let's show a use case with that. So the use case is one of our first GenAI customers, and they are installing pallet boilers at the residential and also at companies. So we are at the service desk. They get a lot of questions, both from customers, also from installers. And the installers are talking multiple languages, but the documentation is only in French and English. So that's often a problem. First of all, let's start just by creating a new agent. There's security by default on it. So by default, you can only call it when you're authenticated within the tenant. We can give instructions, and we give also every agent a single tool to get the current time. I think it's always important that an agent knows what the time is. So that's a tool that we give by default to every agent. So let me show you here the agent configuration. And this session is really not about this accelerator that we've built, but to grasp the way an LLM is thinking and the way you can configure tools and prompts to make sure that it does what it wants you to do. So everything you see over here, you will soon be able to do with agent loop, with Logic App's agent loop. You are already able to do, but not GA yet. So these are the simple settings that you need to create a new agent. You give it a name, select your model. You can select whatever model, and it's extensible, of course. And here you're working for a pallet boiler installation company. And then we give some instructions here. Just if you don't know the answer, be honest about it. Some settings. That's the chat history. If people start to have too long chats, your context that you always send to the LLM grows. So you need to limit that somehow. Otherwise, your LLM will process too many tokens and will maybe throw an exception if you hit the limits. So that's an important one. Here you can configure tools, but this agent is just empty for the moment. So let's waste another token by saying, okay, hello. And the agent should just respond like this. So nothing fancy over here. What's the time? By default, it gets the tool to know the time. So you see here the time is 12:12 UTC. And here you see that it did a function call. So if I click on the details, you can see what happened under the hood. And it did a function call to call the get current datetime in UTC. Okay. There's also security over here. So you can provide your Microsoft Entra ID group. So now I'm authenticated already. But you can also do authorization. You can configure a group. And it can be security group. It can be, what is it, a Microsoft 365 group. So I now need to be in the XYZ group to call the agents. And if I now say hello, I should not get in. Yeah, unexpected error over there. Okay. If I do it away. So normally there's caching on it, but if you use the test console, there's no caching. So if you change something to the prompt, it immediately has an effect. All right. So simple introduction to this. Next requirement. Yeah, we need to search for answers in user manuals. So the customer has many user manuals about the pallet boilers. So if they are asking us questions, we need to find the answer over there. That's actually a pattern that we often have. We need to find for answers for data in unstructured data. That can be product data sheets, it can be user manuals, policies, service desk history, whatever you have. If you have that requirement, there's a good pattern for that to solve it. That's the RAG pattern, the Retrieval Augmented Generation pattern. How does it work? You have, again, a chatbot, an application, an interface, whatever, that sends a question to your API. Your API will search in the systems you want to have available with that question. So we will find relevant information with that question. You can choose to select the top 5, the top 10, the top 15 results to be returned. And then we will call the large language model with a good prompt, of course, with some instructions in the prompts, with the original question of the end user, and with the results that we found in our own system. And that's, again, a way to provide data, or own data, to the large language model. If you have a good prompt, your LLM will generate a contextual relevant answer, and that answer can be returned to the user or to the business process or whatever is consuming this. What's now the problem with this? That's the search thingy. If you search in many of these applications, keyword search will be fine if you have perfect matching. But if the question is in another language, it will be already a problem. If you are using synonyms and all these kind of things that are almost the same, you have a problem. So instead of searching directly on your data, we will search against a vector database. So this is here a simple representation of a vector database where you have a 3D database, but in reality it's a 3000D and even more dimensions in that database. And the closer vectors are, the more they are related to each other. So you see here the animals and the fruits and the vegetables close to each other. Well, you need to see that at a larger scale. So if you have pieces of text that are closely together, it means that they have semantically the same meaning. So what we will do a vector search with the question, and we will ask, okay, we will generate a question. We will generate a vector from the question, and then see, what chunks, what pieces of text, what vectors are close to this vector in the database. And the chances are high that your answer, if the answer is somewhere in the documents, is in these pieces of text. But now we need to get our data to the AI or the vector database. So what do we need to build? An integration. So we need to connect to the source, detect changes. If somebody updates a document, we also, of course, want to have the relevant information in the vector database. If those are PDF documents, we need to extract the text from the PDF. If those are, maybe the source is, in this case, Top Desk, we need to crawl the APIs because that's a service desk tool. So we need to crawl the APIs. Then we have text. We need to chunk it into relevant pieces because, again, your vectors should not be very big. So we need to chunk it in smaller pieces. It's important not to chunk in the middle of a sentence, not to chunk in the middle of a paragraph, and to make sure that chunks within the same chapter belong to each other. You can do it yourself. There are Python libraries. But what I typically recommend is use Azure Document Intelligence. You give it your PDF and you get Markdown back. And Markdown is very easy to chunk. There are quite some good Markdown libraries to do the chunking. You can just give a minimum and maximum size, and it does the chunking for you. And then for every chunk, you need to create a vector. How to do that? That's just calling an embedding model in the cloud. So that's, again, just one API call away. And then you store the results in your vector database. In Azure, that would be typically your Azure AI search. So that's how the RAG pattern works. We made that a little bit configurable. So we have a configurable RAG tool, and we have our own document indexer API. You can throw thousands of documents against it. It will just store them and process them asynchronously with resubmit and all these kind of things, because it's important to have a reliable processing. So we had our existing agents. We will give it an extra tool, and that tool will be to search in the user manuals. The indexing from, in this case, SharePoint to Azure AI Search, we did it already up front. So through that API, just to save some time. But now you will see that the agent has an extra capability to search in user manuals. So if you go here to the second agents and go to the tools, you see I added a tool of the type RAG, Retrieval Augmented Generation. And here you can configure it. You can give it a name and a description. Very important, that description, because that's how the large language model know, what can I do with this? And then you need to select what kind of search do I want to do. You have three options. A vector search, that's what I explained previously. You have keyword search, that's the old school search where you just form a text-based search. And hybrid search is actually doing both at the same time and then taking the best search results. Why do I take here hybrid search? Because often this customer gets questions about error codes that pop up on the pallet boiler, and there you need to have a perfect match. So that's good for keyword search. Vector search is, of course, also good, so let's combine both, and that's why we do the hybrid search. You can choose just the number of search results that you want to return to the LLM. It depends a little bit on the context window that's available over there. And then here we have a search filter on our AI search database. Why? Because there's also a lot of other data in that database. And here we only want this tool to search in the user manuals and not in HR policies or whatever that's also in that database. Okay? So now I can go to the test window and ask a question, for example, what should be the minimum door width to get the boiler into a house? And now, hopefully, it will do a search, a RAG search. Yeah. So you see, it depends a little bit on the type. You have a Palametric compact, you have a condensed, so those are typical different types of boilers. You see that here the search user manuals was executed. Here, minimum door width for pallet boiler installation with that search text. And you see here all the results that were returned. Okay. If you click on this, links should open to the PDF over here. So you can, for example, here see the dimensions where it based itself on. Okay. So when we first tested this, it all worked fine, but then suddenly the testers were saying, okay, we get incorrect answers because you are mixing information from multiple boiler types. So I have a condensed boiler, and you're answering with information from a compact type. And that doesn't work that well. So in order to fix that, we can add an extra parameter to this RAG tool and say, okay, if you want to call this RAG tool, you need to provide the type of installation. So we do that. It's an enum. So let's see how that changes the game. So again, nothing changed over here, but here in my tool, the search user manuals, I added an extra parameter. And that's also something you can do in agent loop. On every tool, you can add your parameter. And this time, I specified installation parameter. It's an enum. And these are the possible values: compact, condensed, smart XS, and classic. Okay. That's all I changed, but here I have also a dynamic filter. So I filter on where the installation type equals parameter installation type. So at runtime, I will update my filter to make sure that we only look into the right types of user manual. So let's try it again. Oh, didn't need to go to there. Let me test this. I get error 123, whatever. You see, the first thing it will ask me is what type of boiler are you using? So are you using the condensed and so on? Oh. Yes, next. We don't always know the installation type, so customers don't know. Luckily, that information is in a SQL database. So that's also something you often need to do. You need to often query structured data, financial reporting data, a product catalog, sensor data, all these kind of things are in a database, so you could query it with a large language model. You could do that for SQL, for KQL, Gremlin, GraphQL. All these kind of query languages are perfect to let the LLM execute queries on your system. There are actually two main options. Or you write the query yourself at design time, and then you make some of the properties or the parameters configurable for the agent to fill in. Or you let the LLM write the queries at runtime. And in that case, you need to give it your schema, your SQL database schema, for example, or your GraphQL definition. And then you let the LLM write its own queries. The first option is the safe option, of course. Then you limit the functionality, and that's very good if you have external-facing agents. There you want to limit what's going on. But the second option is, of course, the more dynamic option and the more powerful option. And that's very good to do data analysis. If you give a database schema to an LLM, and it knows all the fields, and you start asking questions in natural language, it really can do nice things. So depending on your use case, make your query upfront, or let the LLM write the queries. For the demo, I will now let the LLM write the query. But to be honest, in a real scenario, I would do it with the first option to limit the functionality over there. All right? So I will add now two tools to my agent. I will give it a tool, so a function to call to get the database, the CRM schema from SQL database. And I will give it also a tool to execute the query, a query that it can write itself based on the schema that it has. So again, we can do that with agent loop. We can do that with our own code. So here I have query SQL database. Yeah, we have a demo database. So there's a connection string over here with managed identity and these kind of things. And we select the tables that you have access to. So we don't want the full database to be exposed to this large language model, only a few tables. And because this contains two tools, actually, one to get the schema and one to execute the SQL query, you see here that we need to provide two names and two descriptions. Again, why do we make these descriptions configurable? Because they are very important for the large language model in combination with the instructions to know what to do. Normally, I've updated also the instructions over here. Yeah. So if there's an unknown installation type, you can ask for the customer name, and so you can use this tool to make sure that you know what the model, the type of boiler is. So let me try this. I am getting error 1, 2, 3, 4. Then could you tell me the type of installation or provide the customer name? So the customer is Nust. A customer has multiple sites, so multiple buildings. So hopefully it will now suggest the buildings that we have. And you see here, what did it do? It first fetches the database schema. And based on that schema, it executed a SQL query with these results. The nice thing is sometimes it doesn't fetch a schema and just makes up a SQL query, but then it gets an exception. So your exception should return preferably natural language. Then it can interpret it and figure out what's going on. All right. So in this way, I can continue. I can say, okay, it's the first one, or the card. You can type whatever you want. It's natural language, so it will be fine. But, and this error is not explicitly mentioned, but now it did at least. Oh, here, sorry, a search. First, another SQL query to know what's the installation type. It's the compact, and that compact was then provided as an input parameter to search in the user manuals. So. Okay, I'm running a little bit out of time, so I'll continue a little faster. Another question, can we create a support ticket about the conversation? Of course you can, and that's another pattern that we often see. You need to consume APIs. It can be employee data, customer details, sales pipeline that you need to consume. Again, for APIs, you have two options. Or you design, again, your API calls constraints that you want the LLM to let execute and provide parameters to that, a little bit similar to the SQL query, or you let the LLM just choose. And that could be by importing an open API specification and give every API operation as a tool, or by using MCP. So in this case, I will create a support ticket with the constraints stuff, but I will show it later. And then, just to showcase also MCP, we lose a lot of time figuring out the travel times towards the customer. So that's why I created a sub-agent, the navigation agent, which is with MCP connected to Google Maps, so it can figure it out. And that sub-agent becomes then a tool inside our agent, the service desk agent. So it can call the navigation agent, and that navigation agent is then able to go to Google Maps. So if we showcase that last one, you see I added a few more. If you were able to help, then suggest to create a support ticket. If you are not able to help, also suggest it. So if you now test, getting error 5042. So it will ask me the installation type, but I don't know it, but the customer is NUST. Yeah. Hopefully it will now ask for the yes. You can take the first one. Now it should find the reason, yeah, with links to the, can you create me a support ticket? Yes, that would be nice. The support ticket is actually an API call, a post call to ServiceNow that I made available. So support ticket has been created successfully. So if we, it's loading over here. Support ticket should be created in ServiceNow. It's a dev instance, so it's a little bit slower than, yes. So here the boiler under pressure issue and also with some extra information. So it created it for us. And now I need to urgently go to the customer. How long driving? Now it should call my navigation sub-agent, and that one will use MCP, so with all the Google Maps tools, to figure out the stuff. So apparently it's 10 minutes drive, yeah, and actually you see what happened under the hood. It called indeed the navigation agents. All right, so that's how you can use tools to drive the behavior together with instructions of an agent. Next question, can we integrate this in our tool? Because if I get a support ticket, I don't want to go to a chatbot and type it over there. And that's actually a video of one of our customers. This is in Topdesk. So somebody creates a support ticket. It can be through the operations portal, to the self-service portal, or through an email. In the end, that gives us a webhook of Topdesk. Based on that webhook, we invoke a logic app which calls our API, and the result is an answer available in the support tool itself. It's invisible to the caller, so this is an internal comment that we do with some suggestions to solve this issue. So that's really powerful because nobody uses this tool if you need to copy-paste questions into a chatbot, but if you can integrate it into the solution itself in the business application, they are almost forced to use it because it just pops up and it helps them solve the issue. So that's really important. So lessons learned. The magic is in the right combination of instructions and tool descriptions. Very important. Make sure that they are aligned. And if you change your model, you need to change these things again. So that's actually working with another person. If you had a good colleague for years and then suddenly he gets replaced, you need to find another way to collaborate with that person. Key users must be able to adopt, test, and understand your agents. So that's very important. Find a way to let them change the prompts and to also understand the reasoning of the agent, so to see what functions they are calling. When you let LLM write your queries, limit the scope, so don't give them the full database. Limit the access rights, or they can delete your database if you... and give some extra context. Give a possibility for, per table, for example, to add some business information which is specific to your business. When using MCP, MCP can allow you to import a lot of tools. Limit that, because otherwise it could be if you add an MCP server to your agent, that suddenly your agent gets 30 extra tools, which might impact your normal working a little bit. Security is user dependent. If I don't have access to a sub-agent, it should not be available to the kernel. Otherwise, it will try to call the sub-agent and then say, yeah, you don't have access. So actually, the way you dynamically build your agent should be user depending. Find a good balance between the number of agents and number of tools. An agent should really got it around a functional role. And an agent, depending on the model, but can handle up to 30, maximum 50 tools. If you get more tools, you should better separate and go with another agent that then has, again, its own set of tools. And then last one, but very important, integrate the agent in your business processes and applications. If it's not, change is always difficult for people. So if you don't implement the GenAI into the normal working flow, it will not be a success. Even though your chatbot works fantastically, try to integrate it somewhere in the tool set that you have already available. And last thing, change is the only constant, so be prepared. Make sure if you have an architecture, if you have a design, that you can be flexible, that you can benefit from Logic App's agent loop, that you can use features from Copilot Studio. Each tool has fantastic capabilities, but that you can pick the services that Azure provides. So thanks a lot. Dinner is ready to serve, I guess, so enjoy it.